this is Ramax and it's me, Priska Joseph. In my YouTube channel, I am uploading grade 10 NCERT Maths class. If you are watching my classes, please like, share and subscribe my channel. Okay? And you have any comments, please comment it. Okay? So, let's start. In the first chapter, that is real numbers. Now we have to recollect some points from the previous year. Okay? The first one, what is natural numbers? Natural numbers are also known as counting numbers. So, natural numbers are 1, 2, 3, etc. As we count 1, 2, 3, natural numbers are also 1, 2, 3, 4, etc. Okay? Then whole numbers. What is whole numbers? All natural numbers along with 0 is known as whole numbers. Okay? So, 0, 1, 2, 3, etc. These are whole numbers. Then integers. What is integers? Integers is nothing but the collection of numbers positive, negative and 0 are together known as integers. That is a collection of all positive numbers and all negative numbers along with 0 is known as integers. Okay? And finally real numbers. What is real numbers? Real numbers are a set of numbers that contain all rational numbers and irrational numbers. Okay? And the natural numbers are counting numbers, that is 1, 2, 3, etc. All numbers are all natural numbers with 0 and the integers are negative, positive numbers and 0 are together known as integers. And finally real numbers are rational numbers and irrational numbers. And what is rational numbers? Rational numbers. What is rational numbers? A number which can be represented in the form of p by q is known as rational numbers, where p is an integer and q is not equal to 0. That is p by q. Here p is an integer, q not equal to 0. So this is the condition for a rational numbers. Okay. Then my question is 5 is a rational number? Okay, 5 is a rational number because this 5 is also is equal to 5 by 1. So this is in the form of p by q. So it can be represented as p by q form. So 5 is a rational number. Then what about 0? 0 is also a rational number because 0 can be represented as 0 by 1. Okay, is 3 by 0 is a rational number? Of course no. Because here there is a condition, that is p is an integer, q is not equal to 0. Here the denominator q is equal to 0. So 3 by 0 is a 3 by 0 is not a rational number and it is not determined or undefined. Okay. So this is the condition for rational numbers. And what is irrational numbers? Irrational numbers. What is irrational numbers? Okay, irrational numbers are non-terminating, non-recurring numbers. Okay, what is non-terminating? Non-terminating and non-recurring numbers are known as rational numbers. Okay. All non-terminating and non-recurring numbers are known as irrational numbers. Okay. So, what is non-terminating numbers? Suppose a decimal number like 0.3333 etc. This number ends in infinity and repeat the same number. So, 0.33 is a non-terminating number. Okay. Then what is non-recurring? Non-recurring means, recurring means repeating, non-recurring means not repeating. So, for example, 2, 4, 5, 6, etc. Here, these numbers cannot again and again repeating. Okay. Each and every numbers are different and they are not repeating. So, these are non-recurring numbers. Okay. So, this non-terminating and all non-terminating and non-recurring numbers are together known as irrational numbers. Then root 2, root 3, 3, root 5, root 7, etc. Uh, some numbers inside a radical sign, especially all prime numbers inside a radical sign, are generally known as irrational numbers. Okay, so root 2, root 3, root 5, root 7, etc. are irrational numbers. Okay. And the next topic is prime numbers and composite numbers. What is prime number? Simply says prime number has only two factors. That is the first factor is 1 and the second one is the number itself. For example, 2, 3, 5, 7. These are some prime numbers. All prime numbers have only two factors. First one is 1 and the other is the number itself. These are prime numbers. Okay. So next one is composite numbers. What is composite numbers? These composite numbers have more than two factors. So 4, 6, 8, 10, etc. These are some composite numbers. If we consider 4, 4 comes on the table of 1, 2, 4. So these three numbers are factors of 4. So we can consider 4 as a composite number. Okay. Then my question is 1 is a composite or prime? 1 is a composite or prime. So actually 1 is not a prime, not a composite number. Okay. 1 is neither composite nor prime. Okay. What is the reason? Because 1 has only only a single factor, 1 itself. So it cannot be considered as a prime number and it cannot be considered as a composite number. Okay. Hope you understand all the points. And next topic is Euclid's division lemma. It states that any positive integer a can be divided by another positive integer b in such a way that it leaves a remainder r that is smaller than b. Okay, and mathematically we can write a is equal to bq plus r, where r greater than or equal to 0 and less than b. Simply we can say that there are two numbers, two positive integers, that is a and b. If a can be divided by b, then there will be a remainder. Assume there is a remainder r, and what is the condition of r, remainder r? R should be greater than or equal to 0 and less than b. Actually this is a simple division. Okay, let me show you. What is that? That is, this theorem is already we studied in the previous classes. Okay, so this is simple division, that is dividend is equal to divisor into quotient plus remainder. Okay, could you remember this relation? We studied this theorem in our 5th or 6th class, I think. Okay, so dividend is equal to divisor into quotient plus remainder. Let me show you by using a number. That is, if we consider a is equal to 11, then b is equal to what's that? Okay, 2. Okay, then let me show that here when 11 divides with 2, what's happening here actually? We know that 5 2s are 10. Okay, and 1 is remainder. So this is remainder, this is dividend, and this is divisor, and this is quotient. Okay. Dividend is equal to divisor into quotient plus remainder. Okay. So how can we rewrite this relation? That is 11 is equal to dividend 11 is equal to divisor 5 into quotient 2. Okay. Then what is remainder? 1. So we get 10 plus 11. 10 plus 1 is equal to 11. This is this is a simple division method. Okay, what is it? Dividend is equal to divisor into quotient plus remainder. Here A is equal to 11. Okay, what is B? B is equal to 2. Then what is Q? Q is quotient. Okay, what is quotient? Quotient is 5. What is remainder? Remainder is 1. So 11 is equal to 10 plus 1 and RHS is equal to LHS. So this is the Euclid's division lemma. Here the R always should be, the remainder R should be greater than or equal to 0 and less than B. So this is the theorem. Now let me check how Euclid's division lemma theorem is applicable for two numbers. Okay, there are two positive numbers, that is 455 and 42. Here A is equal to 455 and B is equal to 42. Okay. On dividing 455 with B, B is 42, we get 42. Here it is 30, remainder is 35. So this is the method. Okay. So actually what you say is, this theorem says dividend is equal to divisor into quotient plus remainder. Okay, I am writing everything in short. Okay, so dividend is equal to 455 is equal to divisor 42 into quotient 10 plus remainder 35. Okay, it's clearly, and we can understand that 35 remainder is greater than 0, right, and less than this quotient 42. Okay, I'm sorry, not quotient, this divisor 42. Okay, so 35, here 35 greater than or equal to 0 and less than 42. Okay, so we can conclude that any positive integer A can be divided by another positive integer B in such a way that it leaves a remainder R that is smaller than B and greater than 0. So here it is the proof.